In this video, we're going to talk about rate of change, and we're going to be doing it with tables. In the last video, we just did it with graphs, found two different points, subtracted the y's, and then did the same thing for the x's. With the tables, we can do it the same way, so I'm going to show it the same way the first time, and then I'll show you a faster way the second and third time. If we want 2 points, then we can just look at here and here. 1 point is 1, 500, and the second point is 2, 550. To find the change in the y's, you would take the second y, which is 550, and subtract the first y from it, which is 500. To save some space, we're just going to make one big fraction of dividing by the change in the x. How much did the x change to get from 1 to 2? The final number was 2, and the starting number is 1. So we just need to find the difference between the top, which is 50. The difference between the bottoms is 1, and that gave us the change in y divided by the change in x. 50 divided by 1 is just 50. M equals 50. But now let's put those units. Here's the y, and here is the x. We took this salary, we divided by the number of years. And what we saw was we get $50 more every year. For the salary. $50 more every year does make sense, but by adding that it's specifically the salary, it just goes the extra step and makes it extra clear. Now let's do it the faster way. And it's going to be similar to how I did this first example for the graphs. To find the rate of change super fast, we're going to find how did the y change? How did we get from 50 to 75? From 50 to 75 is a plus $25. Then, how did we change to get from 1 to 2? From 1 to 2 is plus 1 days. Then all you need to do is take this number and divide the right one by the left one. Divide the one with the y by the one with the x. And that'll make $25 per 1 day, which is just $25 per day. To show that you don't have to pick the first numbers, let's just do it again and make sure that this slope doesn't change, that the rate of change is the same no matter which points we pick. From 125 to 225. These numbers stayed the same, so we don't care about that. But the 100 digit, the digit in the 100's place changed. We went plus $100, and then the days changed from 4 to 8. To get from 4 to 8, we do a plus 4 days. Now let's make a new division. We went up for the y's by 100, and we went up for the x by 4 days. And what's 100 divided by 4? It's 25, which is what we got the first time. So whenever you're doing a table, whenever you're doing a graph, it doesn't matter which points you pick, you should be able to find the same rate of change no matter what. And if you don't, if it ever happens that the rate of change doesn't stay the same number no matter which points you pick, then the equation is not going to be a linear equation. It might be that you just made a mistake when you're subtracting, but it also might be that it's not linear. So sometimes you should check multiple points unless the equation is already given to you. Let's do a table again the fast way. This is plus $6, and this change was 1 hour. And then I'll just go ahead and label again. This next one is plus 18, and over here is a plus 3. So we should get the same thing if we do 18 divided by 3 that we get if we do 6 divided by 1. How much is 18 divided by 3? The answer is 6. How much is 6 divided by 1? It's also 6. So that means the slope, or the rate of change, for this table is $6 per hour. Okay, so that's how you do it for tables. You can either the same equation you would for a graph, which is just subtract the y's, subtract the x's, or you can draw the arrow like you did for the sequences and just see how is the y changing and how is the x changing, and then you divide those two things.